let's talk about the naming of esters, because they have some kind of one of the more unusual names for IUPAC, the IUPAC system, kind of like our ethers did, where you feel it's just a little different than some of the methods that we've seen before. So here are what I would think are the steps for naming an ester. Step 1, find the ester linkage. Find that linkage and divide the molecule into what I call its two halves. Now, let me explain what I mean by that. An ester has this linkage here that's shown. In the functional group of an ester is that carbon bonded, the carbonyl carbon bonded to a double bonded to an oxygen, and then the alkoxy portion. And that right there, the line, that bond between the carbonyl carbon and the alkoxy portion, that, there we go, right there. That's our ester linkage, and that divides the molecule into its two halves. And what I mean by that is the half derived from the carboxylic acid or the carboxylic acid derivative, and the half that was derived from the alcohol. So in doing that, we're going to identify what I call the carboxylic acid half. So you find your carbonyl group, and all of that, whether it's on the right or the left side, it could be either. All of that over from there is your carboxylic half, and then the alkoxy group, or derived from the alcohol half, is from, so here's my ester linkage. I'm going to put that little squiggle line there. Then the alkoxy portion is the other half. So let's look at a specific example. So let's find the ester linkage. So the ester linkage is, so I find my carbonyl carbon, and then I look for what it's bonded to on either side. So the side with the oxygen, there we go, right there. There's our ester linkage. It's going to be between the carbonyl carbon and the alkoxy group. So now that I found the ester linkage, that helps me divide it into two halves. This half and this half. So let's identify those halves in relation to this. The carboxylic acid half is from the carbonyl, it's the one that includes the carbonyl group. So this is, I'm going to say, my carboxylic acid half. And this, the alcohol half, and it's not an alcohol. So what I'm saying is derived from the alcohol. So the alcohol, or we could even just call it the alkoxy group, the alkoxy side. And we want to identify and locate those because that's going to be really critical in our naming. So once we've done that, use the alkyl group as the first name. So that's the alcohol part of the ester. So here I have a 2-carbon group, which 2 carbons would be eth. So ethyl. So finding that alcohol or alkoxy portion, but we're only addressing the carbon portion, which is kind of funny because we have that oxygen. So how are we going to know that there's an oxygen there? So let me explain that in a bit. So after we've done that, we know that we're going to have an ethyl as part of the name. Then we got to figure out the carboxylic acid portion. So start with the name for the acid part of the structure using the longest chain with the carbonyl carbon. So make sure to count this. I think that's one of the most common mistakes, is to forget to count it. So I have 1, 2. So that's 2. Now, if this weren't an ester, and if it were instead a carboxylic acid, what would its name be? Well, it would be ethanoic acid. But we're actually going to change that. So if it was a carboxylic acid, that would be its name. But we're actually going to drop the ic and the acid. We're going to cross that out. And we are going to change it to ethanoate. Get rid of the ic, replace it with 8. So we still have that O. That's why it ends up O8. Now, you might remember that we do this when we name carboxylate salts. So there's another time where we've practiced this. So then we're going to put it together, and we have ethyl ethanoate. Ethyl ethanoate. Let's look at another one real quick before we do even some additional practice. So here we have, there's our carbonyl group, which makes this the ester bond. And so you'll notice that in terms of identifying my halves, there's my carboxylic acid half, and over here, I'll put a square around it, is my alcohol or alkoxy half. So derived from the alcohol. We'll say derived from, just to make sure we're really clarifying. Derived from the alcohol. So notice they're on different sides. So I don't want you to get the idea that it's, you know, the carboxylic acid is always on the right or it's always on the left. You just have to use the structures to determine it. So this is a 1, 2, 3 carbon group. So its alkyl name would be propyl. And the carboxylic acid portion, the portion derived, this is a 1 carbon group, and so it would be named methanoic acid. But because it's an ester, I'm going to drop that ending portion, the ic acid, and replace it with 8, making this propyl methanoate, or propyl methanoate. So this is kind of weird because we have another situation. We could also talk about a substance, a salt, called sodium methanoate, which is not the same thing, and it's not an ester. Sodium methanoate would be the salt. Here, I'll draw it up here because that's too low in my system. So we would have the ion methanoate, the carboxylic ion, and sodium. So how can we have such a similar naming pattern and understand whether we're talking about an ester or whether we're talking about a carboxylate salt? And really the critical part, I'm going to change color here to kind of emphasize something, is what comes before the word methanoate. If I have just methanoate, I don't really know exactly what I'm talking about. I'd probably assume I was talking about the ion. But if I look at the one before, if it's a metal, I know I'm talking about an ionic compound. And remember, salt is another word chemists use for ionic compound. So as soon as I see that metal, I know that I'm talking about the ion, the deprotonated carboxylic acid of methanoic acid once it gives away its proton. When I see that it's an alkyl group instead, so this is an alkyl group, right? Not a metal, can't find propyl on the periodic table. I know that instead I'm talking about an ester. And I know that these two are linked, this methanoate portion and this propyl portion are linked by an oxygen. So that's kind of earlier what I was saying. We name it ethyl. How do we know the oxygen is there? It's implied by this O8 portion, and this being an alkyl group as opposed to a metal. So that is a little bit weird and kind of confusing. So as always, practice makes permanent, and we want to make sure we engage in as much retrieval practice as we can. So I'd encourage you to pause the video and engage in this practice and play the video to check your work or if you get stuck. So I'm starting here with this first one. I'm going to identify my ester bond, my ester linkage. It's right here. And then I'm going to divide it into its 2 halves. Sometimes I like to do 2 different shapes. Identify the alkoxy versus the carboxylic acid portion. So the alkoxy portion here has 1 carbon group, so it's going to be methyl. And then this is a 2 carbon portion, which would have been ethanoic acid, but I'm going to modify that name to imply it's an ester instead of the carboxylic acid, and so it would be methyl ethanoate. Now, ethanoate, this 2 carbon one, is very, very commonly referred by its non-IUPAC common name, acetate. So you might also see this named methyl acetate, which would be a little bit more in line with its common name. So I'm going to put that there. So moving over to here, let's identify our ester linkage. So there's my carbonyl carbon. I look on either side and I head toward the oxygen. That right there is my ester linkage. And that helps me divide the molecule into its 2 halves. I'll do square for the alcohol derived and circled for the carboxylic side. So what's this? Now this is a benzene ring, right? But I'm not going to call it benzyl. Remember that weird thing, when we are treating a benzene ring as a derivative, we call it phenyl with a Y. So this is phenyl, and then how many carbons do I have? 1, 2, 3, 4. So phenyl butanoate or butanoate, kind of depends. I hear it pronounced both ways in terms, if you're wondering. Now, I intentionally included this one because I want us to recognize a really important thing here. You'll notice we have a benzene ring in here again. So ester linkage right there. Carboxylic acid derived portion, alcohol derived portion. This was derived from phenol. Now, when I go to name this, this isn't phenyl, because this is my carboxylic acid portion. So think about what the structure would really look like if it were a carboxylic acid or in the carboxylic acid form before this ester was created. So that's benzoic acid. And we want to be able to recognize that. That's kind of important to be able to recognize that aromatic, the aromatic carboxylic acid. So when I go to name this, I would name this ethyl, because it's 1, 2 carbon on my alcohol derived portion or my alkoxy portion. Ethyl benzoate, because I take ic acid and replace it with 8. So you can see we can have an aromatic as part of the alcohol group, in which we're going to be needing to use phenyl, or we could have the aromatic be a part of the carboxylic group, and in which case would most likely be using benzoic acid translated into benzoate. So draw the line formula. So this is about taking a name and turning it into a structure, and that's really the beauty of the IUPAC system, that you can go back and forth between name and structure. So I like to start with focusing on the carboxylic acid portion. So pentanoate, so that's 5 carbons, and then O8 tells me that it's either an ion, so we're talking about like a carboxylate salt, or an ester. Now obviously we know from the fact that we're naming esters that it's an ester, but imagine you were on a test or quiz and you had to do that part too. You'd want to look at the thing in front, and since it's an alkyl group, I know that I'm naming an ester, or I'm drawing an ester, and I'm not drawing a carboxylate salt. So a 5 carbon, let's think about what pentanoic acid might look like. So I'm supposed to do line formula. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And then I'm going to end up on my 5th carbon. I'm going to have my oxygen to make it the carbonyl group. And then off of that, because I'm drawing an ester, I know I need an oxygen, and that oxygen is attached to 1, 2, 3 carbons. So you can see there I have, and now all of these happen to have the carboxylic acid on the same side, but remember that don't trust that pattern. So there's my ester linkage. This was derived from an alcohol, so this is my alkoxy group, identified here as the propyl portion, 1, 2, 3, and then I have the 1, 2, 3, nope, I forgot that carbon, 1, 2, 3, 4, 5, my pentanoate, and since I would have called it pentanoic acid, if it was in the carboxylic acid form, I'm going to change that name to pentanoate, or pentanoate. So practice makes permanent. Do as many practice problems as you can.